Good morning, everyone. Thank you so much for joining our webinar today. My name is David Kalmbach, Head of Technical Solutions and Support at FRAMOS, and I'm thrilled to be your host for this session. At FRAMOS, we are dedicated to making latest imaging technology easily understandable and accessible. With that, we are supporting our clients to excel in building innovative imaging solutions of tomorrow. Founded in 1981, our company has a rich history in the classic semiconductor distribution business with a clear focus on image sensors. Over the years, we've expanded our services to cover the entire customer journey. The framework support ranges all the way from technical consultancy, requirements engineering, and product selection over efficient distribution, bring-up support, and troubleshooting. Additionally, FRAMOS provides a robust vision ecosystem that includes reference drivers, supporting IP cores, connectivity, and off-the-shelf hardware solutions, as well as custom solutions tailored to our clients' specific needs. For today, I'm excited to have our long-standing partner Sony joining us to share insights on advances in Sony's 4th-gen global shutter image sensors. I'd like to welcome you joining us for a walk through the evolution from Sony Pregius to Pregius S, illuminating which technology advancements are driving the remarkable market success. Let me kindly introduce you to our two speakers for today, Monique Firozpour, Product Marketing Specialist at Sony Semicon EU, and Giuseppe Contini, Technical Imaging Expert at FRAMOS. I'm looking forward to both of them providing their expert perspective in today's discussion. Here's a quick look at our agenda for the webinar. Right after my short introduction session, I'll hand the mic over to Monique, who will speak for about 15 minutes about advances in Sony's 4th-generation global shutter image sensors. In particular, Monique will show examples and elaborate on how this sensor family affects system design. Monique will then hand over the mic to Giuseppe, who is going to explain how FRAMOS supports enabling customers to create imaging solutions around the mentioned image sensors. After about 25 minutes in, we'll wrap things up with a 5-minute Q&A session where we'll address your questions and provide additional insights. Before we dive in, I'd like to highlight the question feature in this webinar platform. Please use this icon to raise questions during the webinar. Questions will be tackled during the Q&A session. For any unanswered ones, we'll come back to you soon after the webinar. Now, without further ado, let me hand it over to Monique from Sony to kick things off.
Yeah, thank you, David. First of all, hi to both members from FRAMOS team, David and Giuseppe, and to the audience online. I'd like to first thank FRAMOS for bringing this platform for us to talk about our 4th-gen global shutter products. So in order for me to give a brief introduction to our 4th-gen, I wanted to highlight this material that I've provided for the audience. It will hopefully give you a brief introduction into our latest generation of product, the 4th-gen product, which came out in 2019 and still it's very popular. So we're hoping to give you a brief introduction into this product generation. And if you're curious to know more about it, I'm sure the FRAMOS team would be able to book a call with you or go into further detail about this generation of the product. Yeah, next slide, please. Yeah, so let me quickly show you the Sony industry image sensor lineup. So as you might be aware, we've already covered a couple of these product category throughout the FRAMOS webinars. However, today's session is about our high runner group of product, which is our C-mount global shutter products and S-mount. These are a family of product which is very popular worldwide, especially in Europe. However, there are further technologies such as our SWIRE, UV, polarization, time of flight, and EVS. So I'm curious to know what category of product our audience are looking forward to learn further about. So please do let us know which product you're looking forward to learn more. Yeah, next slide, please. Okay, so let's start with basically the generations of these products. So what do we mean by generation? So simply, it's a shorter name to indicate which pixel size we are talking about. So starting from the 1st generation, which is a 5.8 nanometers series of product, then moving on to the 2nd gen, which was a 3.4 series. However, in terms of pixel size, the 3rd gen was a product in middle, which was a 4.5 series. And then moving on to the latest generation of the product, which was a 2.7 micrometer series of products. So these family of products are pretty much covering the same resolution area as our second gen. However, precisely looking at increasing speed and resolution between the 5 megapixel to 24 megapixel. The good news here is Sony managed to reduce the pixel size, making the product smaller and easier to integrate in a smaller and more compact solution, meanwhile maintaining the full well capacity around 10,000. And it's also offered in three famous interfaces, our SLVS, SLVS EC, and MIPI, making it even more easier for a customer to integrate. Yep, next slide, please. Okay, now let me jump into the details for you to understand exactly what is the difference between our families of products in the global shutter and why the 4th gen is a very promising category of products. So first of all, let's start with the word Pregius and Pregius S. These are the Sony trademarks indicating the product is a global shutter technology with a low noise performance and a high precision performance of a Sony technology. Whereas in the Pregius family, this is simply indicating that the technology is a front illuminated structure, which this is a family of the 1st gen, 2nd gen, and the 3rd gen product. Whereas when we are moving on to the next generation of product, the 2019 generation of the product was a backside illuminated stack structure sensor, allowing our product to reach a higher resolution, faster frame rate, and even packed with more functionality. And the benefits of using a 2.7 series product, the 4th gen, is basically you get a wider incident angle, which contributes to higher sensitivity, making it a very ideal solution for factory automation challenges, which require higher sensitivity. We were able to achieve a higher speed by enlarging the size of the metal wiring, and the larger area of signal processing contributed to the better performance of the sensor in the overall area. And as you might remember from a previous webinar that I attended, I already explained our IMX 900, which was even a step higher than the 4th gen product, opening a door into a newer family of product, hopefully. Yeah, next slide, please. Okay, now let's take a look at the products that we have in this family of products. So as I said, it comes into three variations: the high speed, normal speed, and the embedded. We're trying to reach the market with offering the best solution possible. So if the customer is looking for a higher speed, we have the same product and the same resolution in three variants, making it easier for the customer to decide which product would be best suited depending on the cost reduction, speed, or resolution that they are looking forward to integrate in. Yep. And as I mentioned, the embedded version, it comes in a MIPI D5. However, these products are only available up to 12 megapixel. Next slide, please. Okay, now let's talk about the main stories of today's session about the 4th gen product. The success story. I think this is very important in order for our audience to realize, okay, in this big family of product, which product they should look out for if they're ever interested in integrating any of our 4th gen product. Yeah, next slide, please. Okay, here's a quick look at our lineup. So the products in, let's say, pink color. I don't know how it appears on the audience screen. On mine is pink. So these are our 4th gen product. The green ones are the 3rd gen, and the yellow ones are the 2nd gen, and the blue one is our older product generation, the 1st gen. As you can see, we tried with our 4th gen to make it a successor of our 2nd gen. By shrinking the pixel size, we were able to offer the customer the same optical size with a higher resolution product. So, for example, the IMX 530 and IMX 540 have proven to be the most popular product in our 4th gen lineup. and applications are mainly in inspection market, which requires a higher resolution and higher speed. The main reason is the 24.5 megapixel is considered a sweet spot. And since we don't have an alternative in the second gen, the customers are really enjoying the higher resolution with a smaller optical size. Therefore, they are often considered as the most popular product in our 4th gen lineup. The other product, which is I'm very fond of, is the IMX 532 and 542. These are also very popular, especially in the ITS market, due to the 16:9 aspect ratio and the suitable speed for the market, making it the ideal candidate compared to the IMX 387, which has a bigger optical size. So the customer preferred the IMX 532 and 542 as a successor product in order to upgrade their system in future. And at the moment, just to point out, as you might remember, IMX 901 and 902 are also colored in pink. In the previous webinar, we kind of went through the exact definition of IMX 901 and 902. These are still considered the 4th gen family of products simply due to the pixel structure. However, we are trying to target a different market with a wider field of view for these products. And just to give you a good news, you've probably heard the Sony's new series of product called IMX 925 series, ultra high speed 4th generation product. These are meant to be the successor of our most popular product, IMX 530 and 540, for the customers who are looking to even reach a higher speed in this market. So hopefully in future, we will be able to demonstrate those products on our roadmap as well. Yeah, next slide, please. Okay, now just to bring everything back together, what makes a 4th gen product superior? The 2.7 series global shutter CMOS image sensors are, as I said, a backside illuminated technology, new of its own kind compared to our previous generations. This allows a higher resolution in a smaller optical format, which is unique to Sony. Just to give you a good example, for example, looking at IMX 253, one of our most popular 2nd gen product. This product have a package size of 20 by 23 with an optical size of 1.1, whereas our IMX 530 with a smaller package size, around the same optical size, 1.2, is able to reach a 24 megapixel, whereas IMX 253 is only 12 megapixel. So this gives our customer a good ability to easily consider our 4th gen as an upgrade for their system and solutions. Another feature which makes 4th gen superior is our high frame rate, which makes it ideal for giving the customer a higher frame rate with a higher resolution, up to 5 Gbps in an 8-lane. And we also offer these products in a SLVS EC. As I said, always there is a big challenge for the customers. What happens when we shrink the pixel size? Although we are trying to reach a higher resolution, with this affect the full well and the noise level, but Sony's managed to maintain this. And hopefully, if you're interested, you can find the information in the data sheet and comparison between our 2nd gen and the 4th gen, making your decision making even easier. And the last important point that makes the 4th generation product even superior is the functionalities that we added. Although there is a majority of the function from 2nd gen is also available in 4th gen, but in the 4th gen there is new functions such as the dual ADC, which is very important, and the motion detection, making it even more important. So hopefully FRAMOS team will be able to demonstrate this in further session for you. What are the new functionality that Sony added in the 4th gen product? Yep. Next slide, please. Yep, thank you. Yeah, I will hand over to Giuseppe. Hopefully he can carry on.
Yeah, thank you, Manip. This is amazing overview of what is available from Sony and what is coming next. And this is a really nice also because give us the opportunity to support the customers integrating these new technologies and also migrating these existing technologies to new image sensors. So mainly FRAMOS also provides added value distributor, and by added value in this case I'm referring to next slide please David, to the technical support. So we have seen just last slide, Monique was mentioned, okay, higher resolution, high speed. And this is a benefit and also needs to be in some way managed from the system design perspective. We have new interfaces just because the data rate is the product of resolution and frame rate. And here I'm showing how 24 megapixel at 90 frames per second gives about 10 times more data compared to the previous generation of, for example, 6 megapixel at 30 frames per second. So this is a trend of the resolution and the speed that is coming from the market because we all need a faster system, faster conveyor belt, faster production system, but this needs to be translated into technical solution. And in this case, SLVSEC is the proposal from Sony, is a very efficient and effective protocol to transmit high data rate. And FRAMOS is not only providing technical support using it, but in this case, even the IP core for the FPGA. So again, added value not only as distributing products and giving datasheet, but also providing components to connect the image sensor to the system of the customer. So next, we have seen so many sensors. We have seen different characteristics, but then we need to select the proper sensor for the specific application. Here, I'm showing some of the characteristics. Many customers ask me, okay, I need bigger pixel because I want low noise, or so there is not confusion, but in some way, many different characteristics that needs to be combined and considered all together in order to be able to select properly the sensor. We have EMBA certified experts like I am, but not only, all of our team is capable to go into the detail of what is needed for the application. So in low light, for sure, you need absolute threshold sensitivity. In plenty of light, you need full well capacity. In both conditions, you need a really high dynamic range, and so on and so forth. So put all together, it could be not easy. And here, really, FRAMOS technical support can provide good consulting and guidance selecting the product. Small pixel, it's nice because first of all, smaller sensor typically is a cheaper sensor. So budget is happy, but there are some challenges from the lens perspective because smaller pixel means higher MTF required by the sensor, by the system, sorry, and the matching and selecting the lens is not an easy task. FRAMOS has optics expert team as well. Here I'm showing, I like this picture from Sony because it shows also another very important relation between, and here we really need to think at the system level. The wider incident angle of the backside illuminated allows a wider incident angle from the lens. This means that, for example, you can use different f-stop number. And here, just using different f-stop numbers, you have, in this case, in this picture, 16 times more light. So with the same quantum efficiency, your signal increased by 16. And this is only because of the lens. And luckily, because the sensor allows using f1.4, for example. So less shading and much more compatibility. So in one word, you have more freedom selecting the lens. And we guide you on selecting this. Last but not least, also Monique mentioned a lot of new functions, and this needs to be used. So it's nice to have there, but we need to understand how those function works and know how to set up properly in the sensor. Is also here, I have to say this is the core of our technical support, because we come from there, and here really we are talking about register set, register value, and going in through this up to driver implementation or FPGA implementation of the sensor settings using properly the functions that are available. Here I listed some: dual ADC, HDR, multi-sensor synchronization, double exposure. All of these are very, very useful in industrial application, but needs to be addressed and properly managed. So this is a short overview of what can come from FRAMOS in relation to Pregius and image sensor. And yeah, I think that we are there. So
Okay, then
David,
I
yeah,
think
we have more time maybe for questions.
perfect. Thanks a lot, first of all, Giuseppe and Monique, for your great presentations and for all the insights. I'm happy to see that we have also a very curious audience today. So we received plenty of questions. Therefore, it's good that we finished a bit early. We have a couple of minutes more for question and answers. I would suggest we start right away with it. And I guess the first question would be mostly in the direction of Monique. And the question is, with increasing popularity in fourth generation products, does this mean that Sony will start discontinuing of the second generation? There's a bit of a concern that because the fourth gen is so successful, that the second gen might be discontinued. Can you comment on that?
Well, the short answer is not really, because even though our intentions wasn't at all to have fourth gen as a successor, it was more to target a different market, which required higher speed with a smaller pixel size. So, and it's proven to be the correct case simply because our second gens are still continuing to perform very well and increasing in demand. It's just a matter of what customer needs, making it easier for the customer to make decision, and also for FRAMOS to be able to support customer with a plenty of options. So the answer is no. We will continue both the family of product strongly.
Okay, perfect. Thanks a lot. Next question would be more technical one, I believe. Giuseppe, you should be well suited for tackling this one. It's about the interfaces for these Pregius S sensors. Typically, they come in either SLVS or SLVS-EC interface. And we have someone in the audience that would like to connect such a sensor to a embedded VPU like an NVIDIA Jetson. The NVIDIA Jetson only supports MIPI as an input. So I guess the question is, how do you connect such a sensor to an embedded VPU like an NVIDIA Jetson?
Thank you for this question, because in my previous slides, I mentioned the IP core and more. What's that more? Through that, we can also do components for interface conversion. So we are expected to do the SLVS or SLVS-EC to MIPI conversion in a design or in the IP core, or integrating and providing this as a custom solution. But mainly you need a bridge, something that is really converting the protocol. So you anyway need, in case of SLVS-EC, you need an IP core, a receiver IP core that needs to translate it into MIPI. Of course, this is possible only if, and here is back to the topic, the data rate is enough. So if you have IMX 530, it's 24 megapixel at 100 frames per second, or in this case, the amount of output from the sensor does not fit into the MIPI bandwidth. And so in this case, you need to go down in terms of resolution or in terms of data, in terms of frame rate. But in general, this is possible if the receiver part is capable to accept the amount of data that the transmitter, means the sensor, is producing.
Okay, thanks a lot. I mean, this sounds like a really great solution if someone needs the global shutter pixel architecture, but they're not necessarily dependent on the very high speed. I believe this would then be a good conversion solution.
Exactly, and we did that, so we have experience in that, so we know that it works. Not only, for example, even last webinar I mentioned about conversion over GMSL, where we can manage SLVACC to MIPI, then encapsulate into GMSL, and then transmit over very long distance to an NVIDIA Jetson. Yeah.
Okay, thank you, Giuseppe. Next question is about the full well capacity and the impact on signal-to-noise ratio and read noise. So the audience has observed that the full well capacity has a downward trend as the generations progressed because the pixels are shrinking. I believe it's fair to say, and to avoid confusion, actually the idea from Sony was also to keep the full well capacity very high. So also for this 2.25 in comparison to the 2.74, the full well capacity hasn't significantly decreased. Yet, I believe it's valuable to look into the second part of this question. How has the signal-to-noise ratio and read noise actually changed over the generations? Is this something you're prepared to answer in this meeting, Giuseppe or Monique?
Yes, so even the signal to noise ratio is more or less the same, and unless you don't look at a very big pixel like 9 micrometer, but in general, this is the beauty of the fourth generation, where both read noise and signal to noise ratio is almost stable. Not only this needs to be considered in terms of even incident angle. I suggest to do not underestimate this, because the narrow incident angle that you have on previous generation means that you receive less light, or you have much more shading, and so the uniformity of the light that you have is worse than what you have on the 2.74, so latest generation. So all in all, the characteristics needs to be considered at the system level, and at the system level, I have to say that 2.74 last generation of Sony sensor can give very good capacity. Also, there are functions that like a dual ADC that allows to do even HDR with built-in combination of the sensor, and this dual ADC could be used to tackle in low light using low gain and a DC converter, and so there is more flexibility using the sensor itself. So this is also a good feature to consider. Yeah.
Perfect. We do have plenty of questions still piling up. However, we're running out of time a bit, so I would suggest we're tackling two more, and then we're closing things off with that. And for the remaining ones, rest assured that we will come back to you soon after the webinar and answering your questions there. And first one is a quick one. I'll answer myself. The question is about how to get technical support contact to discuss particular implementations. In such case, easiest path would be please reach out to support@framos.com. Thereby you directly reach our technical team, and we will then look into your request and support from there. And the second question is directly a technical one again. It's someone from the audience working in a scientific environment and just being a guest to commercial sensors. They're wondering what is the lowest temperature at which these sensors are actually still working. Has this ever been tested for the image sensor and also the on-chip electronics? Is there some experience value?
Here, I have to stick to Sony datasheet and temperature range because that is the recommendation from Sony. And yeah, lower temperature, what means, but typically, if I don't remember well, is up to -20, they are released up to -20. Going below that, it's something that Moni could comment. Yeah.
Yeah, I mean, this is simple Sony's accountability. We try to give a good number for the customer. -20 is what we guarantee the reliability and the performance. Below that, the product might still operate, but we cannot guarantee the reliability and the performance. So that's why we set a set temperature. Yeah.
Understandable. So thanks a lot, Monip. And maybe also from my own experience, in the end, the sensors themselves are a heater, but of course the bring up would be the issue if you do a cold start. So you may want to consider a preheating of the sensor before you actually heat it up in very low temperature conditions, and then the power consumption of the sensor itself will help you in keeping solid temperatures. Good. With that, let me conclude with what's coming next from FRAMOS. There's two things you surely don't want to miss out on. The first thing on the right-hand side, for sure, these are next webinars of this series. There are two webinars coming up in October, one on October 8th and one on October 14th and 16th about 8K imaging and optimizing advanced Sony sensors in agriculture. So please don't forget to register here, and please sign up also to the FRAMOS newsletter to stay posted for any news and announcements. And the other one, I'm really happy to announce here as well. There's a conference coming up, Imaging Next, built for innovators and powered by FRAMOS. The conference is going to happen September 18th to 19th, 2025, shortly before Oktoberfest. So you may want to combine these two beautiful occasions together. And you will find further information at www.framos.com. What's in there are keynotes, case studies, and panel discussions by industry leaders, and we're going to do a deep dive into vision AI systems designs and real-world applications. And of course, this also exposes a great networking opportunity. There's going to be a lot of members from Sony, NVIDIA, AMD, and other renowned partners of ours, as well as customers presenting their actual use cases. And for sure, there's a lot of industry leaders and experts you will be able to network with. With that, I would like to thank you a lot for your attention, and it's been a pleasure as usual. Thanks a lot again to our great speakers, Monip and Giuseppe. Thanks for all your questions and the active participation of the audience, and wishing you a great day ahead. Bye-bye.
Thank you. Bye-bye.